Hi, you probably learned about differentiation in class today and you're a little confused. Don't worry, I'm here to help. In this video, I'm going to talk to you about the first few basic rules that you have to follow in differentiation. First of all, a lot of people find this really challenging because they feel like they're overwhelmed with a bunch of rules, but I'll try and explain to you all the rules in a more simplistic way, in a way you can understand. I mean, what's written on the screen right now are very formal notations, but I will show you what they really mean. As long as you know these rules, you should be pretty much set to differentiate any given function, ever, really. Okay, so we gotta start with the basic rules. These don't really have a name significant enough to remember, but these are like, if you don't know these, you don't know how to differentiate. Like these are the most basic rules, okay? So the first one, is basically how you derive any function of x to the power of something. So when you have a function written to x with a power, what happens is basically this power, this n, comes down and then you subtract 1. So it becomes this. So the n comes down and gets multiplied to whatever's in front, and then the power gets subtracted by 1. And that's literally it. That's probably almost halfway of what it will take you to derive most functions. So let's say we have a function, say 2x to the power of 4. Simple. You just bring down the 4 times 2, whatever's in front, right? X minus 1 from 4, and it's 3. And so the derivative will give you 8x to the power of 3 to the power of 3. This obviously can be proven through the derivative of first principles. If you haven't watched that video, go check it out. It's the previous video in this video series. And you can prove this if you do it that way, but this is just a shortcut that basically everyone knows. If there's a power, you bring it down and then you subtract 1, and that's what it is. The second rule here, it seems a little complicated, but it really is simple. What it's saying is when you have something that's separated by a plus in between, it means that you can derive the functions separately, and you don't have to worry about them as kind of one function. So say you have a function of f of x that is written as g of x plus h of x, right? You don't have to worry about remembering a special rule that differentiates this. Instead, when you're differentiating f of x, you're just going to be differentiating g of x by itself and h of x by itself. So let me show you what it means. Say you have a function of f of x is equal to 2x to the power of 4 plus 3x to the power of 2, right? And so in this case, we have two different functions that are written separately or separated by a plus. So then all you have to do is differentiate both of them one by one, and then you'll have the answer for the derivative of f of x. And then the last one here is basically if you have a constant in front of a function, then the constant just gets carried over. It doesn't matter. You just derive the function and not the constant, and you don't do anything with the constant itself. So as an example, we have f of x is 3 times x to the power of 4. Similarly to everything, what we've been doing is basically we've been leaving the 3, right, as a constant. This is the constant, this is a constant, 3 is the constant in this case. And then we've been differentiating x to the power of 4, which is just 4 brought down, x minus 1, which is 3. And then you would get 12x cubed. So that's basically it. Those are the 3 basic rules. They're just you just kind of remember them. One thing that you should kind of be aware of is, in this case, if the constant and the function is separated by a plus, these are basically 2 different functions. And when you differentiate a constant, you'll see later, because a constant is basically anything times x to the power of 0, because x to the power of 0 is equal to 1, this is basically equal to the constant, which means if we decide to derive this, it's going to give, when we bring the power down, it's going to be 0 times c times x to the power of minus 1. But we know that anything multiplied by 0 is going to give you 0. So when you derive Any constant basically is going to give you 0. When it's separated by plus, remember, these are two different functions, so you derive them separately. If two different functions are combined by a multiplication sign or a division sign, you can't do this. You can't just derive one and then derive the next. And you'll learn about this in the product and quotient rules. Okay, so now we get into the actual worthy rules, I guess. This is the chain rule. This one's the one that almost everybody gets wrong at a certain point in time because they just decide to forget about it, right? Basically, the chain rule is when there is a function inside of a function. So as an example, let's say f of x is equal to 2x plus 3 to the power of 2. This is technically a function inside a function because the function of 2x plus 3 is inside the function of x squared, right? So this entire thing is taking the place of x in this function. So then basically, this is h of x over here, and this is g of x, right? And so what happens is you basically derive this entire thing as if it was just one function, as if you were deriving x to the power of 2. So you would just bring down the 2, as you would always do. So if we're deriving this, you would bring down the 2, and you just copy down whatever is inside. And then you would subtract, because that's what you do in the derivative, right? And that will give you the power of 1. Now, this is the step that everyone forgets. You can't forget to derive again whatever is inside, right? You just derived this entire function as if it was this, right? As if there was no function inside. But according to the chain rule, if there's a function within another function, you basically have to derive the bigger outer function and then derive the inner function again. So in this case, you would multiply this by the derivative of this, which is basically just 2, right? And so the result would be 4 times 2x plus 3, and you can write this as 8x plus 12 or however you want. But that's basically the point. When you have a function within a bigger function, you basically derive the bigger function, leaving the inner function inside, and then you come back to it and derive the inner function. So you do the outside, and then you come back to do the inside, and then you multiply them both. That's basically the chain rule. And the chain rule, it can be applied more than once. Say you have 2 inside this place of x. Say you have another function, say ex, right? Plus 3 times 2. In this case, you would obviously derive the outermost function first, right? So you would get 2 to the power 2 times 2ex plus 3 to the power of 1 times the inside function, the derivative of the inside function, which is 2ex, right? You haven't learned this yet. I will go through this in a bit. And then you would come back again to the innermost function and derive that. And that would give you 2 to the power of 2 times e to the power of x plus 3, well, times 2e 2x, and then you can simplify this from here. But do not forget the chain rule. This is probably the one where people make the biggest mistakes, and when you have a big derivative, this is where most people go wrong. You have to derive the inside function after you derive the outer function. You can't just derive the outer function and then leave it be. Okay, so that's what the chain rule is. Right, next is a product and quotient rule. And remember how I told you that if the two functions are written not separated by a plus, but they're separated by a multiplication sign or a division sign, well, this is when it comes in place. The product rule and the quotient rule helps us derive functions that are multiplied by each other or divided by one another. And so let's cover the product rule first. This is a really tricky notation, but let me simplify it in terms of triangles and squares as we did it in 6th grade. We have a function, green triangle, right? We have a triangle multiplied by a square. And basically, the derivative of this fx function is going to be the derivative of triangle and then multiplied by just square, plus multiplied by just triangle, and then the derivative of the square. Basically, you can see this as you're taking turns deriving one another and then adding them together. So it's like you derive this one and then you leave this b, and then you plus derive this one and then you leave this b, basically. And that's how I like to remember it. So let's say you have a function like this. Your first response might be to, expand everything and then derive everything separately under the addition rule. But using the product rule it's going to be much more simple. So first thing, what do? We derive the first one, gives us 2, multiplied by just copy down the second function. Plus, we derive the second function, which is 10x plus 3, multiplied by just copy down the first function. And then that's basically it. And then from here, it's just simplifying. You derive one, copy down the next, and then derive the other, and then copy down the other. And then they're added to each other. Pretty simple. Quotient rule is a little bit harder to remember, but it's not that hard. If you follow the order that I go in, it won't be that difficult. So in this case, the order actually matters, right? The order of which one you derive first really matters, because it's subtracted, and when 5 minus 3 does not equal 3 minus 5, right? The order does matter. So in this case, we have triangle divided by square. The first thing that you do is you take whatever is in the top, which is a triangle, and you square it and put it in the denominator. All right, that's the first step, okay? You do that, and then you just copy down whatever was at the top. And then the order from there is just really simple. What you do is you square and you put it at the bottom, and then you copy it down at the top. And now you know that you have to derive, that if you copy down one, then you have to derive the other. So when you copy down the triangle, you derive the rectangle, or you derive the square, and then you subtract and do the opposite, where you derive the triangle and then you derive, and then you just copy down the square, right? Try to remember that. Let's go through an example. Okay, so a pretty simple example, similar to this. Let's take it one at a time. First step, take the top, put it at the bottom, and square it. So 2x plus 3, and then square it. And then at the top, what you do is you copy it down again, right? 2x plus 3. And since you copied this down, now you have to derive the bottom. So you would derive the bottom, 10x plus 3, minus you would derive the one that you didn't derive on this one, which is the top. So you would derive the top, 2 times, leave out the bottom. And there you go. And this is just a matter of simplification. This is simple algebra. You can do this. But this is basically what the quotient rule is. So just remember it in the order that I went in, and then you won't have any problems trying to remember these silly, very complicated looking notations. So far we've only been looking at functions that have a constant number in the power and x at the base, basically. But what happens when we have an exponential function where x is in the power and not in the base, right? So we could have things like e to the power of x or a to the power of x, and that would be considered an exponential function. We can't do, contrary to what most people think, we can't just bring down x, subtract 1 from x, and say this is the derivative, because that is not how it works. We need a different rule, and that's the rule that we use for exponential functions. Okay, so let's start off with the one that we can remember most easily. E to the power of x. This guy's a pretty special one, right? When you derive it, it's going to be the exact same, right? So let's go through an example. Say you have e to the power of 2x, right? Simple enough. Your first initial response might be to say, okay, well, it's the same, I guess. Well, why don't we just write e to the power of 2x? And this is where you go wrong. This is not the answer, because according to the chain rule, when you have another function inside a function, right? So in this case, the function 2x is in place of x, right? So there's a function in another bigger function. You derive the outer function, and yes, that's correct. The e to the power of 2x will be the same, but you still have to derive the inside function and multiply it. So then you would have to multiply by 2. And so your answer would be 2 to the power of, 2 times e to the power of 2x. And that would be your final answer, not just this. So this is what I mean when people forget the chain rule. This is really important, right? So that was an example. This one's really easy to remember. Anything e to the power of x, the derivative of e to the power of x is just going to be e to the power of x. It stays the same. This is the only one that stays the same. However, if you don't have e in your base and you just have any number, right, then things get a little more different. Basically what happens is you write down the exact same thing that you have, a to the power of x, and then you multiply it by the natural log of that base number. So it will be a to the power of x ln a. So let me show you what I mean. If we have an example, I'm just plugging in numbers at this point. I'm pretty sure you guys are not stupid enough to not know this, but if I have 5 to the power of x, say it would be 5 to the power of x times ln 5, and that would be the answer, right? And the reason why ex stays the same when it's derived is because ex, technically, when you derive it, it becomes e to the power of x ln e, and we know that ln e is just 1. So that's why it becomes ex, right? That's why it seems like it doesn't change, but it actually does go through this. So e to the power of x doesn't change. Any number to the power of x, you have to include ln that number, basically. Okay, lastly, we have log functions. Let's start off with the easier one again. When we have the natural log of any x, right? If we have ln x, the derivative of that will be 1 over x, right? There's not really a way to remember this. You just kind of say, okay, ln x is 1 over x. That's really it. There's no clever way of remembering it. You just got to remember it, okay? So we do a simple example. Say we have ln 2x squared plus 3, right? Then we would do this. We would derive the outer function, say 1 over 2x plus 3, and then derive the inside function, which is going to be 4x. And so the final answer will be 4x over 2x squared plus 3. Don't forget the chain rule again. On the other hand, when we don't have natural log and we're working with log of any base, right? So that could be log 2x. That could be log 10. Well, log 10, you wouldn't really write 10, but log 10x. You get the point. With any base number in here to the power of x, this is what you would do. So it would be the same as this, right? 1 over x, but in the denominator you multiply the x by ln of whatever that base was, right? A little weird to remember, but you just kind of got to remember it that way. Let's do an example. Okay, so say we have log of 3x cubed plus 2x, right? And so what we would do is we would derive it in this way: 1 over 3x cubed plus 2x, right? This is the x, this is the x. And then we would do the natural log of whatever this base number is. When we don't write anything, it's 10, right? So it will be ln 10. Don't forget the chain rule, times 9x squared plus 2. So the final answer would be 9x squared plus 2 over 3x squared plus 2x times ln 10. So those are the most simple rules of differential calculus. When we get into trigonometry, it's going to get a little bit more tricky, but a little more to remember and a little bit more tricky. But as long as you know these rules, you know pretty much half of everything. Remember that you have to do the chain rule or you're going to get things wrong. And if you have a bunch of things that you have to derive, you miss the chain rule in one step, every other step is just going to get messed up. So make sure you remember the chain rule and correctly remember the product, the quotient rule, the exponential rules, the logarithmic rules, and even the basic rules, right? So take another look at this video. You can rewind and rewatch to kind of understand my thought process of when I'm using the product and quotient rule, when I'm using the exponential rule, when I'm using the logarithmic rule, and just kind of try and understand this, because when you get this down, differential calculus is going to be a breeze for you. I completely mean it. If you calm down and follow the rules, this chapter is not a hard chapter, okay? So go through the video again, look at my thought process, and you will be perfectly fine. Sorry if this video was a little long. I really wanted to show you what my thought process is like when I'm solving these questions and when I'm trying to recall the product rule and quotient rule and the order of how things happen. So hopefully this helped. I will be making a part 2 to this, talking about the trigonometric rules, I guess, covering sine, cosine, tangent, cosecant, cosecant, cotangent, and secant, as well as the inverse rules, arc sine, arc cos, and arc tan. So yeah, I hope that helped. The next video is going to be on trigonometric functions because we have a lot to cover. If you have any suggestions on videos that you want me to make in either Math A HL, Physics HL, or Chemistry SL, you can leave it in the comments below and I will try and make that as soon as possible. So yeah, hope that helped. I'll see you in the next video.